Hello everyone, welcome to homework 11. In this lesson we're going to be rationalizing the denominator. This lesson is going to be with one term, and then the next lesson will be with two terms. This is actually the first lesson here that you're not going to need for your pre-calculus class. So all 10 lessons and homeworks was to help you be more prepared and to get that foundation for pre-calculus. Starting with this lesson to the end, this is stuff that you're going to possibly need after pre-calculus. And so rationalizing the denominator, we'll get to that here in a minute. Before we start rationalizing the denominator, we need to go over a couple rules that have to do with radicals. So the first is the product rule, and we actually already went through this one here when we were in lesson 4, simplifying radicals. As long as these indexes here are the same, then we can multiply what's under the radicals together. So example 1 says multiply, simplify if necessary. So we have the square root of 7 times the square root of 11. Even though we don't see it, there's little known 2's right there, right? That's the square root. And so we can put those together and say this is 7 times 11, which gives me the square root of 77. Okay, we've done this before, right? Same thing on B. We've got 15 times 5, so they're both the square root. So we can do 15 times 5. 15 times 5 gives me 75. And then that can be simplified. So the biggest square root that can go into that is 25. And so my final answer here is 5 times square root 3. Okay, now with C and D, we don't just have radicals, we have things in front of them. Same thing, you multiply what's on the outside of the radicals together. So 2 times 3 gives me 6. And then you're going to multiply what's under the radicals together. And so we get square root 30. And that's actually our final answer. If you break that down, that's 5 and 6, which is 2 and 3. You don't have a pair of anything. Another way to think about it is a perfect square doesn't divide evenly into 30. So that is my final answer. Okay, same thing on D. Multiply the outside with the outside, inside with the inside. So I've got 5 times 4 to give me 20. Then we've got 42 times 2 to give me square root 84. And 84 can be broken down. The biggest square root that divides into 84 is 4. So I've got 4 times 21. The square root of 4 is 2. And so when you already have something on the outside and you're bringing something out of that radical with it, we're going to multiply those together. Right? So the square root of 4 is 2. And then 20 times 2 gives me 40. Okay, you're not going to have any homework questions over this, but this is a skill we need to do to be able to rationalize the denominator. Another thing we're going to need to do is the quotient rule for radicals, and we haven't gone over that one yet, but it's super simple. If you have a square root of a fraction, you can simply divide that up where you have the square root over the square root. So you have an example of that right here. So we had the square root of x over 16. So we change that to the square root of x over the square root of 16. And now the square root of 16 simplifies to 4. A lot of times that's the way we do use it, but you can see here it does work the other way too. So you have the square root of 75 over the square root of 3. Well, we can look at that and say, I know 3 divides into 75. So they put that square root together. So they have the square root of 75 over 3. 75 divided by 3 is 25. So the square root of 25 is 5. More times than not, we're going to be using it this way, but it does work both ways. So example 2, use the quotient rule to simplify. So I don't know what the square root of 36 over 49 is, but I can split that up to the square root of 36 over the square root of 49. The square root of 36 is 6. The square root of 49 is 7. And then that is fully simplified. Same thing here. This is a lot like this one right here, right? If you can technically go from here to this step here, you don't really need that middle step. Okay, but that is technically what we're doing, so I am going to write it. So we have the square root of x over 25, so I'm going to change that to the square root of x over the square root of 25. The square root of x does not simplify, but the square root of 25 is 5. Okay, we're going to need that on a couple of our problems too. So, all right. It says right here, often in mathematics, it is helpful to write a radical expression such as square root 3 over square root 2, either without a radical in the denominator or without a radical in the numerator. We're not going to do any of this today, but that will be in the next lesson. More times than not, you're wanting to get that radical out of the denominator. It is not technically proper to have a radical in this form here, or a rational expression in this form here. It's considered improper form to have the square root on the bottom of that denominator. And so the process of writing this expression as equivalent expressions without a radical in the denominator is called rationalizing the denominator. So the reason I said you could use this, depending on who your calculus teacher is, or depending if you're doing homework in my math lab, this could be your correct answer, but because it is in, I'm putting quotes, you can't see my quotes, but an incorrect form, it won't take this answer, or maybe your math professor won't like this form. And so you're going to have to write an equivalent expression of this answer without that radical in the bottom. So you may or may not technically need this. A lot of times though, if you're like when you're in your calculus class as well, even if your professor takes this answer here, they're going to have the answer wrote in rationalized form. And so to be able to check your answers in the back of the book to make sure you're doing your work correctly, it would help to also rationalize that denominator so you can check your own work. So here are your steps for rationalizing a denominator, and this is only with one term, okay? You're going to multiply the numerator and the denominator by the radical in the denominator. When you do this, this is where all we're going to be doing, because you're multiplying the top and the bottom of your fraction by the same thing, that means that this right here is going to equal 1, right? So if I have 5 and I multiply it times 1, that doesn't change its number. I can change the way that this 1 looks though, right? If I say 5 times 3 over 3, well, what does 3 over 3 equal? That equals 1, right? And so if you multiply, you get 5 times 3, which is 15. 1 times 3 is 3. 15 divided by 3 is 5. This is what we're going to essentially be doing. It's just the way that we're going to write this 1 is not going to be very pretty. It's going to get even uglier next lesson. So step 1, multiply a numerator and denominator by the radical in the denominator. Make sure all radicals are simplified. And then step 3, simplify the fraction if needed. So in 1, we're going to multiply the top and the bottom by whatever is that radical in the bottom. So because we have square root 5, we're going to multiply this by square root 5 over square root 5. Again, that just equals 1, right? So I'm not changing it, just changing its form. So now multiply. We got 1 times radical 5 to give us radical 5. Square root 5 times square root 5 is square root 25. I can't do anything to the top, so that's going to stay as square root 5, and then the square root of 25 is 5. This is my final answer. This and this are equivalent expressions. If you put this in the calculator, you're going to get the same decimal as this right here. And so that's a really good way to check, right? If you get in calculus, if you get this as your answer, and the back of the book says this, another way other than rationalizing the denominator is to put it in your calculator and check it and see if you get a decimal equivalent. Same thing on B. We have a square root 7 in the bottom. So I'm going to multiply this by square root 7 over square root 7, which equals 1. So in the top, we've got negative square root of 11 times square root 7 to get negative 77. And then on the bottom, square root 7 times square root 7 gets me square root 49. 77 doesn't simplify, so that's going to stay as negative square root 77. And then in the bottom, square root 49 comes out to 7. So before we go on, I want you to make sure you notice and see two different things here. Notice first off, I have a 5 and a 5 in the bottom and top of this fraction here. So first thing, I can't simplify that. Just like up here, where we multiplied the outside with the outside, then the inside with the inside, same thing here. I can't simplify if 1 5 is inside a radical and 1 5 is outside of a radical. Same thing here. It's tempting to divide them both by 7. Okay, but again, 1 is inside of a radical and 1 is not. So make sure you're not simplifying insides with outsides. Second thing, I don't know if you've noticed this or picked this up, but I'm going to come over here and put a little side note. Notice here, when I did square root 5 times square root 5, what did we end up getting once we simplified? We got a 5. Here we did square root 7 times square root 7. What did we end up getting? 7. If you multiply the same thing together under a radical, it's going to end up coming out. For example, square root 10 times square root 10. One way to write that is the square root of 100, right? 10 times 10, which ends up becoming 10. But another way is to do 10 squared. That square root and square cancel each other out, and we get 10. This happens with variables as well. Square root x times square root x. Well, that's going to give me x times x is x squared. The square root and square, they're opposite operations. They cancel each other out, and you get x. So from now on, I am going to go straight from here to here. We're going to skip that middle that middle step. Okay, on C, we got 6 over square root 10x. So we're going to multiply top and bottom by whatever radical's in the bottom to get rid of it. So I'm multiplying by square root 10x over square root 10x. On the top, one's outside a radical, one's inside, so they don't mingle. This becomes 6 square root 10x. It's the same as if you did 6 times x. You just smush them together, right? Same thing there. Okay, over square root 10x times square root 10x, we have just learned, comes out. Now here we can simplify. I can't simplify anything with that square root 10x. Even though that exact same thing is in the bottom, one's inside a radical, one is not. But I can simplify 6 over 10. Divide them both by 2. And we're going to get 3 square root 10x over 5x. Okay. D, 3 square root 2 over square root 6. I don't care what's in the top. I don't care if I have a radical on the top. We're going to multiply both by square root 6. So now I have 3 times, if you want to think of that as a 1 right there. So we've got 3. 2 times 6 gives me square root 12 over square root 6 times square root 6 is just 6. We can do some simplifying here. So first off, let's simplify this radical. The biggest square root that goes into that is 4. Square root of 4 is 2. So I've got 3 times 2 and then square root 3. 3 times 2 is 6. And those 6's do cancel. So my final answer there is just square root 3. Again, notice, even though I have a multiple of 3 in that radical, you can't do anything with that. Okay, we couldn't have divided right here 12 divided by 6. Doesn't work like that. E, technically what we need to do first is use that quotient rule and split that up. I can simplify the top, so I might as well. The square root of 16 is 4. So I've got 4 square root x. Because I have an x in the bottom, or no, not because of an x, because I have a radical in the bottom, we need to rationalize. So we're going to multiply by square root x over square root x. And the top, one's outside the radical, one's inside, so that just becomes 4 square root x. And then square root x times square root x equals x. All right, and then lastly on F. I'm going to solve this one 2 different ways. If we're following the rules that I've set out before you, what we would do first is split that up, and then we will multiply by the radical in the bottom, right? Square root 50. So square root 5x times square root 50 gives me square root 250x over 50. We can simplify square root of 250. That is the same as 25 times 10x. Okay, that's my biggest perfect square root that can divide into 250. over 50. The square root of 25 is 5. And then I can simplify this. Even though 5, 10, and 50 are all divisible of 5, I can only reduce 5 and 50. So if I divide them all by 5, that's going to become a 1. So I'm not even going to write it. We've got square root 10x over 50 divided by 5 is 10. Okay, so that's not so bad. But if I pick it up from right here, I had square root 5x over square root 50. What you could do is simplify the bottom first and deal with smaller numbers. So the square root of 50 is 25 times 2. Square root 25 is 5, so we get square root 5x over 5 square root 2. And now, if you have something in the bottom that has a number outside that radical, you don't even worry about that radical. I would multiply by just square root 2, right? That's what it says in here, by the radical in the denominator, not the whole term. Okay, so in the top, they're both under radicals, so we'd get square root of 10x. Square root 2 times square root 2 is 2. So we'll do 5 times 2. And then we get 10. Okay, so either way, you're either going to have to simplify in the middle, but you're going to get bigger numbers because you're dealing with bigger numbers. Or you can simplify from the very beginning and deal with small numbers. Either way, you get the same answer. So that's all I have for this lesson. Let me know if you have any questions. Next lesson, we're going to be rationalizing the denominator with more terms. So it gets a little bit more messy, but it's still not too bad. It's still the general idea. Bye, guys. See you next time.